Okay, trig students, take your notes out, open up to 3.1b, the Law of Sines. We come to ambiguous cases. So far, you've been able to solve for, using the Law of Sines to solve for triangles with no problem. Today we come to, this will be the most difficult portion of your study, is when we encounter possibly no solutions or two solutions or one solution. Now, if you remember from geometry, when you use congruence theorems to prove that triangles were congruent, you either had side, 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 angle, side, angle. You had angle, angle, side. You also had side, angle, side. But the one that did not work was this one. If you spell it backwards, it looks like this. And we all know that spells a bad word. So that means that it can't be used to prove that triangles are congruent. And therefore, it can't be used, and we sometimes come up with two solutions or no solution in that process. So anytime you're in a situation where you're given two sides and not an included angle, you end up with this problem. Let me go to your decision tree so you can see exactly how that plays out. Again, we started off with angle, angle, angle. If you're given three angles, there's no solution at all. If you don't have any sides given, you got no chance solving that triangle. If you're given two angles and a side, then there's one unique solution. You guys have been practicing that. If you're given two angles and an included side, again, one solution using the law of sines. So all of these involve having at least two angles. This one involves just having one angle, but two sides where the angle is not included. We need to become very smart when we do this. You follow the decision tree down if that's the case that's given to you. And you follow it over to either of these two situations. And the first one suggests to us that we have a side opposite the angle is shorter than the other given side, or the side opposite the angle is longer than the other given side. You need to decide which one that is. Based off of that information, you are then going to encounter either two solutions from this case or no solutions, or in this case, one unique solution. Now, I'm going to draw it out so you can understand. I know this is a lot to take in, but you'll have some time to practice. If we go back to your notes and we check out this problem right here, these part of the notes which suggest, what does side-side angle with an opposite leg that is shorter look like, where you have two solutions. This is something that you've probably seen happen in geometry. Now, I'm going to fill in this box here in just a second, but for right now, I'm going to move to another page where I already have a drawing prepared. As you notice on this page, I have an angle, I have a side, and then another side that I'm going to draw in. So angle, side, side. The dotted line on the bottom represents another side, which I'm not given, but we know that it makes some sort of the angle. I don't know how long the side is. Well, you notice if I take this side, which is 10 units long, okay, if that one's 12, I suppose 10 would be right about here. Notice that this triangle right here, okay, it satisfies these properties. A side of 12, a side of 10, and an angle of 40. But if I swing this like a pendulum, I've created another triangle that looks entirely different. It also has a side of 10, a side of 12, and an angle of 40. I've changed none of those three stipulations, yet I have a totally new triangle. Notice again, 10, 12, and 40, 10, 12, and 40. Now, I know I'm not doing that perfectly, but you could get the idea that it's hard to tell exactly which side that 10 should go on. And that creates our problem. That's exactly what we need to lay out. So we go back to our notes. We'll just kind of sketch that in to the best of our ability. Down at the bottom here, you can have, if the opposite legs, so say this is 12 and this one's 10 at 40 degrees, that's one possible triangle. Or you can have 12, 40, and 10. Two different shaped triangles depending on which side that pendulum swings on. The other thing that can happen is if you have, let's make a new triangle, very similar though, okay? 12, 40, and then again, the side opposite the angle here, it could possibly be too short. Say it was 2 units long. There's no way at 2 units long it could stretch all the way down and make it to that side. So in that case, there are no solutions. So those are the two situations that we can come up with there. If you flip over, there's one that kind of works out better for everybody else. So uh, this one says opposite leg is longer. So we'll try that. Let's say that, again, you've got 40 degrees, you've got 12, and then let's say that this side is 16. Well, there's no way that the 16 can pendulum over to the other side. So again, if the opposite leg is longer than that, then there's one unique solution. One unique solution. There's only one triangle that can be drawn. So each time we're going to follow our decision tree and see exactly what we come up with and try to solve these. So we're gonna draw the triangles and try to figure them out. So here we go. A is 22, B is 12, and A is 42. All I do is I sketch my triangles. Sketch one, call it A, B, and C. Angle A is 42 degrees. Side A is 22. B is 12. Now, in this situation, I look and I'm given an angle, a side, and a side. You don't have to flip to it, but I'm going to. On my decision tree, angle, side, and side leads me to right here. If I have angle, side, and side, I follow it down. I need to decide, is the side opposite the angle shorter, or is the side opposite the angle longer? Let's check. If I go to the side opposite the angle, 22 is longer than 12. My decision tree says I have one unique solution. Use the law of sines and solve. So I set it up. Sine of 42 over 22 is equal to the sine of B over 12. Notice the difference here. We're solving for an angle. Solving for an angle. I take out my calculator. Times the sine of 42, 8.03. 8.03 is equal to 22 sine of B. Divide both sides by 22. 0.3650. 0.3650 equals sine of B. Now, what I need to do is inverse that value, second inverse sine of my answer, and I come up with a grand total of 21.41. Going to write that down. A is 42, B is 21.41. I think that was right. You have 21.41. Finding C, I could take on my calculator. I could subtract from 180. 180 minus 42 minus 21.41. We get 116.59. There, I have all my angles. Now I'll do my sides. A, B, and C. A is 22. Whoop. B is 12. C, I have to solve. So I set up the law of sines. Sine of 42 over 22 equals the sine of 116.59 divided by side C, which we're trying to solve for. Using what we've done the past few days, we cross multiply, divide, and solve. So I'll have 22 times the sine of 116.59. And I will divide that by the sine of 42. That gives me 29.40. Side C is 29.40. And there you have it. There is a solved triangle using the law of sines, recognizing, again, that the opposite side, this one here, was longer than the other given side. That's one solution. One solution. Use my decision tree. We'll move on to the second one. I'll erase this, give myself more room. This one, side A is 15. Side B is 25. Angle A is 85. Draw my shape. Call it A, B, C. A is 15. B is 25. A is 85 degrees. Notice, I have, again, angle, side, side. The opposite side, 15, is that longer or shorter than 25? It's shorter. So I go to my decision tree. My decision tree says, I follow it down. Opposite angle is shorter. So I follow it down and I see what it says. I see that when I solve for the missing angle, if sine of theta is less than 1, then there are two solutions. Or, when solving for the missing triangle, I might come up with sine of theta is greater than 1, then there are no solutions. So I don't know which one this is going to be. I'm gonna have to work through it. So we'll work it out and see what we come up with sine of theta to be. We'll go from there. So I'll set it up. Sine of 85 over 15 is equal to sine of B over 25. We get out our calculator. (25) times the sine of 85 is 24.90. So 24.90 is equal to 15 sine of B. Divide by 15. Divide that side by 15. We get 1.66. 1.66 is equal to the sine of B. Now, we inverse, sine inverse of our answer, and we get, hey, domain error. If we go to our domain error, sure enough, you can't inverse the sign of that answer. Sine can never achieve a value that's greater than 1. And because of that, there is no solution to this problem. So my video is almost ready to run out, so I'll try to cover here what we can, and then we'll start up again. But if you look here, we've covered a couple really, really important things. And what we've said is that using side-side angle, if you decide that the side opposite the angle is longer, there's one solution, which we did. If you decide the side opposite the angle is shorter, then we came down here and realized that it says sine is greater than 1. There is no solution. So you can guess that the next problem we do will be this one. And that's the hardest one. We'll solve it through. We'll start a new video and do it.